Hey guys, I'm away today, but I just feel it's important to keep going with the good work. Okay, so as promised, I'm going to go through this question. Okay, caused some of you a bit of bother yesterday. It's 2 minus root 5 over 2 plus root 5, and we're asked to simplify it. And remember, we don't like roots as denominators. Okay, so what we do here is we will multiply the denominator and the numerator by this, but we're going to change one of the signs. Okay, we're going to change one of the signs because we know when we take this and change one of the signs and multiply this by the whatever we've changed the sign to, it'll give us just a real number. Okay, so we have 2 minus root 5. So I've taken that and I've changed that to a minus root 5, and I'll do the same on top, because if I have a fraction here and I multiply both numerator and denominator by the same thing, then the fraction doesn't change. Okay, so again, right, so Laura, no, you can't just multiply the 2 by the 2 and the root 5 by the root 5. Okay, we have to go this by this and then this by this. So 2 by 2, 4. 2 by minus root 5 minus 2 root 5. And then we have the minus root 5 by the 2, which is again minus 2 root 5. And we have the minus root 5 by the minus root 5. Well, minus by minus is a plus. Root 5 by root 5 just gives us a 5. Okay? And now we're going to multiply these two. Now, again, I'll go back to you, Laura. This is why you probably made the mistake of just multiplying the 2 by the 2 and the 5 by the 5. Because if you multiply the 2 by the 2 and the root 5 by the minus root 5 here, you will get 4 minus 5, okay? But that's kind of just a fluke because the root 5s will cancel each other out, okay? So stick to how we learned how to do it. So 2 by 2, 4. 2 by root 5 minus 2 root 5. Then plus root 5 by 2, which is plus 2 root 5. And then plus root 5 by minus root 5 is minus 5. Okay, so that's the true answer, but these will cancel each other out. Okay, so this will equal, well, so it's 4 plus 5 is 9, minus 2 root 5 and minus 2 root 5 is minus 4 root 5. And that's all over, well, minus 2 root 5 plus 2 root 5 it just is 0, and 4 minus 5 is minus 1. Okay, so there's your answer. Now, Lucy, you asked me a very interesting question, okay, but we kind of just flew through it, but I just want to go back on it. Lucy asked me, you know the way I take this number and I change that sign, okay, to a minus. Well, Lucy asked me, what if I don't change that sign? What if I change the sign up here to a minus 2? Will it work? The answer is it will. Oh, we'll just show you what actually happens. So we go again, okay? So again we have 2 minus root 5 over 2 plus root 5. But this time Lucy's after deciding, instead of changing the second sign, she's going to change the first one. Okay, so we've minus 2 plus root 5, and again we'll multiply the top by the same, minus 2 plus root 5. Okay, so just I'll work these out down here. Okay, so it's 2 minus root 5 by minus 2 plus root 5. Okay, so 2 by minus 2, minus 4. 2 by plus root 5 plus 2 root 5 minus root 5 by minus 2 is plus 2 root 5, because a minus by minus is a plus, and minus root 5 by plus root 5, well, signs are different, so minus, and root 5 by root 5 is 5. Okay, so that would be our top done out, which is minus 4 plus 4 root 5, because we have the 2 root 5 plus 2 root 5 minus 5. Okay, now the bottom, so 2 plus root 5 by minus 2 plus root 5. Okay, so first by first, first by second. 2 by minus 2, minus 4. 2 by plus root 5, plus 2 root 5. Second by first, second by second. So root 5 by minus 2 is minus 2 root 5. And plus root 5 by plus root 5, signs the same, so it's plus root 5 by root 5 is 5. Okay, and if you notice here, well, actually we'll write it up. Plus 2 root 5 minus 2 root 5 plus 5. Now, can we just simplify the numerator and the denominator? So minus 4 minus 5 is minus 9, and minus 9 plus 4 root 5. And the denominator then will be minus 4 plus 5 is plus 1, and the 2 root 5 and the minus 2 root 5 will cancel each other out, so I'll put the 1 here. Right, if you notice something, 9 minus 4 root 5 over minus 1, or minus 9 plus 4 root 5 over 1. It's the same answer. Okay, same answer, is just the signs have changed around, which actually doesn't make a difference, because watch this. Let's say I go minus 3 over 2. Well, minus 3 over 2 is minus 1.5. Okay, now if I change the signs around, 3 over minus 2, well, that's still minus 1.5. So because the signs just change around, you still get the same answer. Okay, so in answer to your original question, yes, you can. You can just choose. You can choose to change the first sign as well. Okay, as long as you just choose one. Okay, so hope that one helps. This one then, a little bit different. This time, instead of simplifying, we're asked to minus one from the other. Okay, so I think it was Holly yesterday or today copted that she said, well, and it was Robert as well. Actually, how about we think back to our algebra and we think, what does this and this go into? In other words, what's the common denominator? Well, 2 minus 1 root 2 plus 1. Okay, and ask yourself then, how many times does this go into this? So how many times does root 2 minus 1 go into root 2 minus 1 multiplied by root 2 plus 1? Well, the answer is root 2 plus 1 times, and there's the 1 on top, so we'll stick it there just to keep it neat. The minus, and then how many times does this divide into this? Well, the answer is this many times. Okay, so root 2 plus 1 divides into root 2 minus 1 multiplied by root 2 plus 1, root 2 minus 1 times. Okay, so this divides into this many times. So again, we put the 1 there, and it's root 2 minus 1. Okay, now, well, the top would be easy. So it's 1 by this, 1 by this will just stay the same. So it's root 2 plus 1. And then we've minus 1 outside. So that minus 1, so think about it. We need to multiply everything inside the brackets by this minus 1. So root 2 by minus 1 is just minus root 2. And minus 1 by minus 1 is plus 1. Okay, and then down here, well, look, it's the same number, but just the different sign. So we know we should get just a real number here. So let's see. This by this, this by this. So root 2 by root 2 is 2. Root 2 by 1 is plus root 2. Then minus 1 by root 2 minus root 2. And minus 1 by plus 1 minus 1. And then we just simplify it out. So the top will give us, well, we have a root 2 minus a root 2, so they're going to cancel. We have a plus 1 and a plus 1, so we have a 2. Okay, and then over here we have a root 2 and a minus root 2, so they're going to cancel again, and we have 2 minus 1, which is 1, and 2 over 1 then is 2. Okay, so hope that helped. Okay guys, so now we're going to have a look at this question. Okay, so it's equations involving roots, and we're asked, this is page 73, question 7, part I, and we're asked to solve for x. And I think just Holly very cleverly said, well actually I want to get rid of the square root, so I'm going to square this side. Okay, brilliant. Again, we'll put in our stabilizers. Now if we square this side, it's just going to get rid of the square root sign. So we'll have 2x plus 1. Now if we square this side, we're going to get 9. We have a nice handy linear equation there. So if I take 1 from this side, I'm going to get rid of that 1. But I also have to take 1 to the other, because remember our balance. Okay, we have to keep that balance. That equal sign means balanced. So we'll be left with 2x equals, well, 9 minus 1 is 8. So 2x's is 8. So if I divide by 2 on this side, we'll do the same to the other. And 2x divided by 2 is x, and 8 divided by 2 is 4. Okay? The next one then. Right, a little bit more tricky. Okay? But again, we'll do what Holly said. We'll square this side to get rid of that square root. That square root is going the whole way across. Okay, so it's squaring the x, square root in the x and the 5. So I'll in my stabilizers, and I'll square this side, and I get x plus 5. Okay. Now if I squared all this side, I have to square all that side. Okay, but I can't do what Laura likes to do, which is just square that and square that. I need to square it all. So if you think about it, the handiest thing to do is put brackets around it. Now, all of that squared means all of that multiplied by all of that. So I'm going to write it out here. 5 minus root x squared. Yeah? Well, that's the same as 5 minus root x multiplied by 5 minus root x. And I think it was Laura Kiley then copped, and she said, oh, but hold on, this is a minus and this is a minus, and we don't like that because it's not going to give us a whole number, or a rational number. And she's dead right, but there's nothing we can do about it, because we can't just change this to a plus because we're asked to square it. So we're going to just have to deal with it. So let's go, let's square it out and see where it brings us. So 5 by 5, 25. 5 by minus root x is minus 5 root x. And then this one, minus 5 root x by 5, is another minus 5 root x. And then minus root x by minus root x, well, minus and minus multiplied together, like signs give, plus. And root x by root x is just x. Okay, I'm going to simplify this, and we have 25 minus 10 root x, because the minus 5 root x and the minus 5 root x gives minus 10 root x, plus x. Okay, now throw this back in. So we have 25 minus 10 root x plus x. Okay. Now I think it was Lucy then said, well, look, it's a bit of a mess, but sure, maybe I can tidy things up. Okay. So I'll just start getting rid of stuff. Okay. So I wouldn't mind getting rid of that x. Okay. So I'm going to take away x on this side. Now if I do it to this side, I have to do it to the other. So take away that x, and I'm left with 5. And over on this side, I'm left with 25 minus 10 root x, and that x is gone. Okay, well, how about I take away this 5? Okay, I'm just getting rid of things here. Okay, so I'm going to take away that 5. So take away the 5. Take away the 5. And that'll be 0 equals what? 25 minus 5 is 20 minus 10 root x. And then I'm going to have to end up with x's on one side, numbers on the other. So if I bring this 20 across, or I suppose what I should say really is, if I take away this 20, okay, so I'll take away the 20 on this side, I need to take it away on that side. So if I take away 20 from this, I'll just be left with minus 10 root x. And if I take away 20 from this side, I'll actually have a minus 20. Okay, and I think it was Laura O'Donnell said, well, if I divide minus 10 into minus 20, will it be a plus or a minus? Well, the answer is a plus, because like signs give plus in multiplication and divide. But me personally, I just like to change the signs the whole way across, so I'm dealing with pluses, which I can do. Okay, so 20 equals 10 root x. Okay, same thing, but I just get rid of the minuses. Now, so 20 is the same as root x multiplied by 10. That's really saying. So if I divide this side by 10, I'll just be left with root x. But if I do it to this side, I have to do it to that side. So divide this by 10, and I'm left with 2. Load of us got to there. Okay? But we're not finished yet. We want to know what x is. We know this, the root of x, square root of x is 2. But I want to know what x is. How do I get rid of that root? I square it. And I'll have x. But if I do it to this side, I must do it to the other. So x is 4. Okay? Right, I hope that helped, lads, and I hope it irons out any problems for you. So the work that I'd like you to do for now and for I suppose the next, maybe tonight if you can, and again, I don't want you to spend any longer than half an hour at this, okay? So half an hour for homework is more than enough, as long as it's good, good, just a good effort put into the work. So I'd like you to actually start on page 73, question 7 and 8. Okay, so start that now. They're just what we've been doing. Okay, so question 7 is nice and handy. Question 8 is more like them. Okay, I've actually done the first one for you. Right, so I've done what I suppose a sixth of your homework for you. This is the one I want to see how you get on with. Right, I will just give you one hint. Okay, maybe I'm ruining the magic on you by saying it, but Pythagoras' theorem. Okay, see what you come up with. It's just think Pythagoras' theorem and see what you get. Okay, I'll see you tomorrow, lads. Thanks.